For over a century, California's Lassen Peak slept in silence, until now. In just the last minute, satellite sensors recorded the ground rising half a meter as a surge of deep tremors echoes beneath the surface. Scientists confirm this is no false alarm. Magma is pushing higher than at any time since 1917. If history repeats, the eruption could be catastrophic. But what triggered this sudden awakening, and how far might the danger spread? The evidence starts here. February 2025 brought a breakthrough few expected. Scientists pored over satellite radar images, INSAR interferograms, searching for any sign the mountain had shifted. The data showed something impossible to ignore. The ground near Chaos Crags had lifted by nearly half a meter in just weeks. This wasn't a subtle signal. The deformation pattern covered the summit, with the greatest rise centered directly above the youngest domes. At the same time, a team processed magnetotelluric slices, mapping how electricity moved through the earth beneath Lassen. Their results revealed a zone of low resistivity, a fingerprint of heated, partially molten rock pushing upward. The boundaries of this anomaly matched the area of ground uplift almost exactly. Dr. Elena Ruiz, a USGS volcanologist with years of experience on restless volcanoes, led the analysis. She had flagged the anomaly as soon as the first radar frames came in. Ruiz and her team worked around the clock, cross-referencing satellite passes and electromagnetic profiles, determined to rule out seasonal snowmelt or atmospheric distortion. The pattern held steady. Every new pass confirmed the original finding. The ground was rising, and something deep below was changing fast. The team's report, finalized in March, left no room for doubt. The combination of rapid uplift and a fresh conductive zone pointed to new magma intruding at shallow depth, closer to the surface than at any time since the last eruption over a century ago. For Ruiz, the evidence was as clear as it gets. She pressed for immediate peer review and called for seismic teams to corroborate the intrusion. The mountain, she argued, wasn't just stirring. It was moving from within, and the data was the first hard proof. The next step, confirm if the Earth itself had started to tremble. Seismic analysts turned their attention to the ground beneath Lassen, combing through 6 months of continuous data. The region's network of broadband seismometers, though thinned by years of budget cuts, still captured the subtle pulse of the Earth. In late autumn, an unusual pattern began to surface. Instead of the sharp, high-frequency jolts typical of tectonic quakes, sensors picked up low, rolling vibrations, low-frequency tremors, spreading outward from the heart of the volcano. These signals stood out in spectral analysis, their energy concentrated in the 1 to 5 Hz range, far below the crisp snap of ordinary earthquakes. The difference wasn't just in pitch. Tectonic quakes hit hard and fade fast, but these tremors lingered, sometimes for minutes, sometimes for hours, building and fading in slow waves. Analysts mapped the epicenters and saw a radial pattern, with tremors radiating from beneath Chaos Crags toward the broader volcanic center. This was not random noise. The pattern echoed the seismic signatures that once preceded the 1980 eruption of Mount St. Helens. Low frequency, migratory, and persistent, as if something deep below was stirring magma and fracturing rock along the way. Comparisons with historical data confirm the anomaly. In a typical year, Lassen's seismic catalog is scattered with small, shallow quakes, most registering below magnitude 2.0. But these new tremors carried a spectral fingerprint that matched volcanic unrest elsewhere, a slow, droning resonance, sometimes accompanied by tiny bursts of high-frequency energy, hinting at fluids or gas moving through cracks. The outward spread suggested internal pressurization, magma or volatile gases rising, meeting resistance and flexing the crust above. For the analysts, the signals were both warning and puzzle. The tremors didn't break the surface or trigger rockfall, but their presence, radiating outward in a widening circle, gave weight to the ground deformation seen from space. The volcano was not just swelling, it was sending a seismic message, one that demanded a closer look at the hidden structures beneath Lassen's summit. Beneath Lassen's fractured summit, the story shifts from surface signals to the hidden world of molten rock and gas. Seismic and gravity surveys show that the volcano's core is not a hollow chamber, but a layered system of partially melted rock, what geologists call mush zones, stretching from 4 to 8 kilometers below ground. These reservoirs are thick with crystals and pockets of melt, able to trap and release pressure in unpredictable bursts. Closer to the surface, between 2 and 5 kilometers down, sits a melt-rich zone. It's here that the magma is freshest and most mobile, its heat and dissolved gases building up beneath the brittle crust. Even a small injection of new magma, just 5/100ths of a cubic kilometer, can flex the ground above, opening fractures that let volcanic gases escape. The pressure doesn't need to be enormous to make an impact. The crust in this region is already fractured, weakened by past eruptions and ongoing hydrothermal activity. Dr. Elena Ruiz and her team focus on these subsurface mechanics, studying how the mush zones respond to new magma pulses. Their models suggest that as magma rises, it heats and softens the overlying rock, creating pathways for gas to move upward. The release of carbon dioxide and sulfur dioxide, combined with increased heat flow, can destabilize the shallowest layers, sometimes triggering explosions without warning. The sensitivity of this system is remarkable. A small increase in melt or gas can tip the balance, fracturing the crust and sending tremors outward. The threat is not just from a single eruption, but from the potential for rapid, cascading changes. As pressure builds in the mush zones, the risk of hydrothermal explosions grows. These blasts can hurl rock and ash across the landscape long before any lava reaches the surface. For those tracking the signals, the challenge is clear. Even minor shifts deep underground can have sudden, explosive consequences above. A narrow band of dying trees stretches along the north shore of Manzanita Lake, their roots tangled in soil that now steams on cold mornings. Field teams from the USGS and UC Davis press metal probes into the earth, logging temperatures several degrees above average for early spring. The readings are unmistakable, an increase of up to 5 degrees Celsius at just 1 meter depth, far beyond what seasonal warming could explain. Gas sensors register carbon dioxide levels above 1,500 parts per million, with sulfur dioxide spiking at intervals that match recent deformation events. The air holds a faint, acidic tang, and patches of moss have turned brittle and brown. Every few steps, a scientist kneels to collect a soil sample, careful to avoid pockets where CO2 escapes in visible wisps. The pattern is clear. Wherever the ground has swelled, the forest is thinning, replaced by bare trunks and scorched undergrowth. The team's notebooks fill with coordinates and numbers, each point tracing the invisible boundary between living forest and a zone claimed by volcanic gases. These tree kill scars are more than ecological wounds. They are a warning, proof that magma is forcing its way upward, changing the chemistry of the land before anything erupts to the surface. In the spring of 1915, the air in Redding turned thick and gray as ash drifted down from Lassen Peak. Diaries from local families, preserved in the Shasta Historical Society, describe midday skies so dark that lanterns were needed to milk cows. One entry recalls the steady fall of fine grit-coating fields, clogging streams, and turning laundry on the line a dull, sullen brown. Farther up the valley, a surge of mud and debris, what geologists now call a lahar, raced down Lost Creek, sweeping away fences and barns. Photographs from the time show houses half buried, their porches swallowed by hardened volcanic mud. Letters sent from Plumas County speak of livestock lost to poisoned water and entire orchards suffocated under a heavy blanket of ash. The eruption did not just scar the land, it upended daily life, forcing families to flee and leaving entire communities to rebuild from the mud. For descendants who still live in Lassen's shadow, these stories are not distant history. They are a reminder that the mountain's silence is never permanent and that every sign of unrest carries the weight of what happened before. Lassen Peak is only the most visible summit in a landscape shaped by volcanic forces. The Lassen Volcanic Center sprawls across 200 square miles, a network of domes, craters, and ancient calderas that stretches far beyond the mountain's snow-capped cone. Geologists map more than a dozen major vents here, each a possible source of future eruptions. Cinder Cone, to the northeast, last erupted in 1666, leaving behind a stark field of black lava and ash. Chaos Crags, just 1,000 years old, rises in jagged spires above the forest, its youth marked by unstable slopes and frequent rockfall. The land is riddled with hidden scars, collapsed domes, steam vents, and fumaroles that vent heat from the Earth's depths. This is not a single volcano, but a restless field where magma finds many ways to the surface. For scientists, the complexity demands constant vigilance. A change at one vent can signal unrest across the entire system. The challenge is clear. Hazard planning cannot focus on just Lassen Peak. The entire volcanic field must be watched, mapped, and understood. In a region this vast, every gap in monitoring becomes a risk, not just for one mountain, but for all the communities living in the shadow of California's sleeping giants. In the years following the last eruption, a silent erosion set in, not of rock, but of vigilance. By 2015, federal and state funding for volcano monitoring at Lassen had slipped below half of what scientists requested. The result was immediate and visible. 1 out of every 3 sensors was taken offline. Seismic stations, gas monitors, and ground deformation arrays, vital tools for catching the earliest signs of unrest, fell dark across the volcanic field. Some were dismantled and never replaced, their concrete pads left to weather in the forest. Others simply expired, victims of aging batteries or corroded wiring, as maintenance crews shrank and priorities shifted elsewhere. For the scientists tasked with watching over Lassen, each lost sensor meant another blind spot on the map. The network, once dense enough to triangulate even subtle tremors or minor gas leaks, became patchy. Key areas around Chaos Crags and the north shore of Manzanita Lake, sites now showing the most dramatic signs of change, were left with gaps in coverage just as new signals began to stir beneath the ground. The remaining instruments worked overtime, but with fewer eyes on the mountain, the margin for error grew wider. Internal reviews from the USGS and California Volcano Observatory show how these gaps complicated every step of hazard assessment. Analysts struggled to verify whether odd seismic blips were real or just digital ghosts. Gas readings arrived late or not at all. Even satellite data, powerful as it is, depends on ground truth from sensors that can confirm or reject what the images suggest. In meetings and budget hearings, volcanologists warned that the next eruption could be missed in its earliest stages, not because the mountain was silent, but because the tools to hear it had been allowed to fail. The cost of prevention, once seen as a safeguard, had become a gamble with consequences that no one could fully measure. A memo dated February 2025 circulated through the inboxes of agency heads and county planners across Northern California. Its language was clinical, but the warning was unmistakable. Current sensor coverage is insufficient to guarantee early detection of magmatic intrusion at Lassen. The document never reached the public. Instead, its contents triggered a wave of quiet urgency behind closed doors. Policy analysts from the Office of Emergency Services pored over risk overlays, updating evacuation maps that now stretched beyond the old boundaries. 7 counties, Shasta, Tehama, Plumas, Lassen, Modoc, Butte, and Sierra, were redrawn into the expanded hazard zone. Over 50,000 residents found their homes, schools, and elder care facilities newly marked for priority evacuation. The new overlays flagged major transport routes for rapid clearance, with GIS files handed off to local planners and first responders. No press conferences, no sirens, just silent preparation as county officials reviewed lists of at-risk sites and ran drills on paper. A county planner in Plumas described the mood as tense but unspoken. We ran models for a full-scale eruption. The numbers were sobering. Every route, every shelter, mapped and color-coded. But we kept it all internal. The last thing anyone wanted was a panic before we had answers. The memo's impact rippled outward, its existence hinted at in cryptic agenda notes and off-the-record calls. For residents, life continued as usual. But in back offices and emergency command centers, the reality was clear. The ground was restless, the sensors were too few, and the responsibility for early action now belonged to people, not machines. The mountain's warning was not just seismic, it was institutional, written in the language of risk and response. At Manzanita Lake, the gates are closed to all but a handful of tribal elders. For the Atsugewi and Maidu people, the shoreline is more than a scenic stop. It's where generations have gathered for ceremony, healing, and remembrance. Now, as county officials weigh closures, tribal leaders are forced to choose between tradition and safety. One elder puts it simply, "The lake is not just water, it's where our ancestors speak." Loss cuts through our entire people. Down the road, the Summit Ridge Lodge sits nearly empty. A chalkboard still lists last year's fishing derby winners, but the parking lot is bare. Since early March, cancellations have wiped out 90% of bookings. The owner, hands folded behind the front desk, recalls the collapse. "We went from full bookings to funerals for our business in 8 weeks." Layoffs rippled through the staff. Local markets and outfitters followed, each closure echoing the uncertainty that now hangs over the region. In the midst of these upheavals, the scientific debate rages on. Independent volcanologists argue late into the night over the possibility of a chain reaction, whether pressure changes beneath Lassen could ripple north, disturbing the deep conduits that link the Cascade volcanoes. Some warn that even small pulses in the mush zones could trigger unpredictable shifts, not just here, but as far as Shasta or Crater Lake. Others urge caution, pointing to the limits of current models and the stubborn unpredictability of partially molten rock. For residents, the future is a question with no clear answer. The ground is restless. The forest is thinning. Booking ledgers and ceremonial calendars lie in limbo, suspended between hope and fear. With every new report, the only certainty is uncertainty itself. In 1914, Lassen Peak's eruption covered towns in ash and forced communities to adapt overnight. Today, over 50,000 residents live within the expanded high-risk zone mapped by county officials. Scientific records confirm Lassen sits atop a complex system of magma reservoirs, with historic eruptions at Cinder Cone, Chaos Crags, and Lassen itself. Despite decades of calm, monitoring budgets dropped below half of requested levels by 2015, and a third of sensors were decommissioned by 2018, leaving gaps in early warning capacity. archival documents show that, in February 2025, a confidential USGS memo warned of insufficient sensor coverage to guarantee detection of new magma movement. While scientists have documented the region's eruptive history and mapped its volcanic hazards, precise forecasting of the next event remains out of reach. What happened here a century ago is not forgotten, and the risks are real. For now, the people of Northern California and the scientific community remain vigilant, watching for the next signal from beneath Lassen Peak.